Alright, welcome to our last set of videos. This is stuff that'll help us prep for pre-calc and some of the things you're going to see there, which is like the next level of the functions we have now. What we're going to take a look at are polynomial functions, functions with a lot of different terms. What matters most is the very first term, which will be the term with the highest exponent. So we're going to take a look at what we call the end behaviors of these graphs. So y equals x cubed, y equals x to the fourth, y equals x to the fifth, and y equals x to the sixth. The whole idea is if we can look at these four, then you can predict what graphs after this will look like, such as y equals x to the seventh, x to the eighth, x to the ninth, and all that stuff. Even if they have coefficients like 12, x to the fifth, we should be able to predict what's going to happen. Alright, let's take a look at these four parent equations and what their graphs look like. So y equals x to the third will look like, yes, like that, which we should be somewhat familiar with. X to the fourth will look like that, which should be familiar to us as well. X to the fifth looks something like that. And x to the sixth will look something like that. Alright, now what we're going to look at is what happens if we have more terms, more what we call polynomial functions. So that's x to the third, has a lot of terms in it, but that's still a cubic function. It's going to look like that. So look at the similarities above with what you have below. X to the fourth, that's a polynomial with its focus will be the x to the fourth because that's the highest power. That's going to look something like this. Boom. So in your calculator, if you graph it, it's going to look like that. X to the fifth as a polynomial function will look like that. And then x to the sixth as a polynomial function will look like this. So the top row are their general looks or their parent graphs. Below is when there are terms added to it. Now see if you can take a look at all of them and catch some patterns. Alright, let's go through all of them together. Yx cubed, when it's cube is your highest power. As it goes to the left, whoops, let me go back a little bit. As we go to the left, the graph goes downward. As we go to the right, the graph goes up. Oh, whoops, what happened? Oh well. What we're going to take a look at is how it goes from left to right on all of these. Now let's go to the bottom row. So x cubed, we got a cubic function. What happens as it goes to the left? Same thing as above. And x to the fourth, what happens when it goes to the left? Same thing as above. Oh, and to the right. Sorry. As we look at all of these, the graphs, when you go from left to right, they have the same properties. So we look at our x to the fourth graph. As you go to the left, it still goes upward, and as we go to the right, it goes upward. So above it, in the regular parent equation, y equals x to the fourth, it does that. And then down at the bottom, when you've added some pieces to it, or polynomials, it still does that. The end behaviors still go in the same direction. Now let's take a look at x to the fifth. As you go to the left, it still goes downward, and as you go to the right, it goes upward. And then x to the sixth, boom, same thing. Even if you have a coefficient, even if you have extra terms, as you go to the left, it goes upward, and as you go to the right, it goes upward. So what we want to do is take that and predict what's going to happen with other equations later on. Okay, so take that all in, let it sink in. Remember, we're looking at what we call the end behaviors, the beginning, where the arrows are. What we really want to look at is where the arrows go. Now let's take a look at all of them. When you have x squared, x fourth, x to the sixth, our graphs tend to look like that. Oops. No, not like that. Let's go back a little bit. Let's go back. Let me clean this up. Sorry. Alright, now we're back on track. Oh, let me pull this all the way back. As we look at these, Well, we'll notice as x goes to infinity, so as we go to the right, your y value, or the whole function, is going to also go towards positive infinity. And then, as our x moves towards negative infinity, which means it's going to the left, our y value, or f of x, is going towards negative infinity as well. So it's pointing downward. So we kind of need to make these connections. So what that means to us is you can predict the end behavior for something like x to, whoops, what am I doing here? Where to go? X to the, what you can do is you can predict the end behavior for anything that has x to the 9th power, x to the 11th power, or in general anything that's x to the even power. Or, my bad, odd. Oh shoot, what am I doing? So anything that's, did I get that right? Odd. Let me erase that. So, whoops. So anything that is odd, we can predict its behavior. Now, let's move to our even powers. So that graph in general, x squared, x fourth, x is 6, it has that general quadratic form, but it'll start to have these little bumps and hills in the middle. As x goes to infinity, as x goes to the right, your y value, or f of x, will go upward or towards positive infinity. As we go to the left, as x becomes negative, your y value, or f of x value, will also go towards infinity for anything that is even. Well, let's clean up these. There we go. Anything that is even. 8, 10, anything that is even. Alright, so let that sink in. This is called end behavior. As you see equations with these exponents on them, you should be able to predict how it's going to be on the left side and how it's going to be on the right side, known as end behavior. Alright, thank you very much. Bye.